But he spent a great deal of time just rolling balls down an inclined plane, carefully recording the distance they traveled as a function of elapsed time. And he had experiments that were commonly repeated in physics classes today. So we're going to actually repeat a similar lab compared to what we're going to cover today in our pre-calc class. And so the question is what graphical model fits this data, and can you find an algebraic model that fits? So the top row is just time, and it looks like he measured it every second. And the bottom row is just how long or how much distance did the ball roll down this inclined plane. Now, inclined plane is like a ramp. So to do that, the first thing we need to do is we just need to open up our calculators and enter the data in the list. So if I hit the stat button, remember if I come down here to set up editor, it resets everything in my stat thing, and then if I hit stat again, I may need to clear a list. Didn't have to. So I'm gonna do the top row first. So I'm gonna put time in for L1. So I'm gonna say 0, enter, 1, enter, 2, enter, 3, enter, 4, 5, 6, 7, 8. Right? Is that right? And then I'm gonna come over to L2, and I'm gonna hit 0.75, 3, 6.75. 1, 2, which is 12, 18.75, 27, 36.75, enter, and 48. Now, as you observe this data, what do you notice? What are some numbers that you notice that kind of stick out to you? We've got some 0.75s, every other number, and then it looks like there's a pattern, right? I'm not quite sure what the pattern is, but it looks like there's a pattern. So I'm going to check and make sure my y-vars is cleared, and then I'm going to turn on my stat plot. Notice that mine's off, so I got there by hitting second Y. See this little word that says stat plot in yellow, so I have to hit the yellow button to access that menu. I'm going to hit enter again to turn that on. By default, it says L1, L2, which is good because that's where I put the data. And then I'm going to come over to graph, and I can't see all the points. So since I can't see all the points and I want to see all the points, what I'm going to do is I'm going to hit zoom and come down to zoom stat. Now zoom stat is what you use a lot in the stats class, and all that does is it figures out all the values for L1 and L2 and finds the minimum and maximum. Since L1 represents the x values, it takes a little bit lower than the lowest value in L1 and a little bit bigger than the maximum value in L1, and it fits that to your x parameters of the window and does the same for L2 and the y parameters. So now what does that look like to you guys? What kind of function does that look like to you guys? And I'm going to sketch the graph here. What kind of function does that look like to you guys? Yes? Thank you.
It looks like it could be half of a quadratic.
Yeah, it looks like a quadratic equation. So what I could do is I'm just going to sketch this. So on your homework, I can't see your screen. And what you could do is you could just simply kind of sketch this, kind of freehand it. It doesn't have to be perfect. Right, Mr. Adams, you know, and you're just kind of sketching it. So this is example number 4, right? And you could probably write the data down if you want to. You don't have to. So it looks like a quadratic. So one thing we could do is let the calculator calculate it. Now, if you take stats next year, they'll actually teach you how to calculate it by hand. But for now, we'll let your calculator do it. So we're going to hit stat again, and this time we're going to go to the calculate menu. Now, we call fitting data to a mathematical model a regression, and since we think it's a quadratic equation, we're going to do a quadratic regression. So when I hit enter, by default, it'll automatically pull the information up. Okay? Now, what that's saying is, on your calculator, it's saying that y is equal to ax squared plus bx plus c, and then it gives us that a is equal to 0.75, B is equal to 0, and then C is equal to 0. So really what they're saying is that our equation is 0.75x squared, right? That's what they're saying. Now, I want to show you that if you come in here and hit Stat, go to Calculate, and then go to Quad Reg, we can automatically plug that equation into our grapher. So what I want to do is you could hit the vars button, go to yvars, select function, and then choose y1. And now if I hit enter, what it will do is it will store this information as this equation into y1. Whoops, I hit the wrong button. Okay, it still spits out the information, but now when I go to y1, notice it plugs the data in the equation in. So now when I hit graph, I'll see the line and it goes right through the dots. Now sometimes it won't always go right through the dots. This problem was kind of rigged up for us, right? Are there any questions on that? So what does this mean? Well, remember Galileo measured distance over time, so what was the independent variable in this scenario? The time or the distance? Well, let me rephrase that. Which depends upon the other? Does the distance depend upon the time, or does the time depend upon the distance? Okay, we got two trains of thought, so let's do it this way. If you think that the time depends upon the distance, raise your hand. Oh, if you think the distance depends upon the time, raise your hand. If you want to go home and go back to sleep, raise your hand. All right, we all agree on that one. But what it is that the distance depends on the time. The more time that passes, the further the distance is. So what we're really saying is that we can calculate how far something will roll down an inclined plane by using this equation, if we know what the time is, okay? Another thing to keep in mind is that L1 is usually the independent variable. Where L2 in the calculator is the dependent. Now, sometimes you got to remember that because the book won't tell you, especially in your stat class, and if you accidentally put the wrong variable in the wrong spot, you'll get a wrong answer. Okay? Okay, good.